Bonjour à tous, and hello everyone. If you don't mind, I might switch to English so that everybody can understand. So the aim of today's talk is to review all the possibility that fiber optic give us for the surveillance of power cables, may it be inter or export cables. So first off, before going into the details of the technical of what we can do, what we can propose, I think it can be interesting to present who we are. So we're a French company specialized in distributed fiber optics, meaning that we can measure various things using optical fiber, may it be acoustics, temperature, and strain, which we usually call DAS, DTS, and DSS. So we're French-based in Pau, but working worldwide. And our 4 key points would be very high performances. It's the first thing that we put because it's really our core value to have very high quality data with a good cost to quality ratio, of course. And if we want to be effective in an industrial world, we need to be sufficiently robust and easy to use so that the output is useful for the client. We also have a test center which allows us to test our units in site conditions, not just do tests in labs and say, yeah, it's going to work on sites. We can reproduce site conditions as to make sure that it will work on the client site. And of course, since we are a manufacturer, we are ISO 9001 to make sure that our units are of highest quality and repeatable in terms of performances. So once again, we're French-based, so all our manufacturing and engineering is going to be done in France. But we work worldwide with representatives throughout the globe. And as you can see, in yellow, we have worked a bit of everywhere. So we'd be glad to assist in different projects. One quick slide before we move on to the more technology bit on the test center. So once again, it's a very unique tool because it allows us to test our systems in site conditions. And since it was built on our blueprints, we can really use it directly to test what we want to do. It's not adapted, it's recreated to be able to represent site conditions that are important to the application that we measure. So it's very nice, and you're more than welcome to come and visit us to see this tool because it's quite unique. So now to the bit more interesting bit than who we are. It's what technology do we use? How is fiber optic capable of making measurements? So to make it simple, actually it's quite fascinating because you don't really need much. All you need is a telecommunication fiber, standard one, single mode or multi-mode. And what you do is you plug the fiber on one end to our unit and it becomes a sensor. Instead of being used as a telecommunication, as transmitting information from point A to point B, we get information throughout the cable, meaning that every meter, every 5 meters, we will get an information on temperature, strain, and vibration of this cable. So this is due to different effects that we call Rayleigh, Raman, and Brillouin. And it's very nice because, once again, nothing needs to be changed. We can use an existing fiber optic cable, an existing fiber that has already been laid, and plug our system into it as to get measurements. So it's so once again, it can measure temperature, acoustics, and strain. And the good thing is that it gives you information throughout the cable. It's not a specific location that is going to give you information. It's every meter through tens of kilometers, up to 70, even 100 kilometers, just with a single unit plugged into one end. So it's quite nice because you don't need to have access to both ends to make a measurement, what we call a single end measurement. You can access a very long range with a single unit, and there is nothing in line, so nothing to be added on the cable to make a measurement. Also, that means that you don't need to bring electricity or communication lines to each location at the equivalent positions, since it's the fiber itself that gives information. So passive measurements, very interesting in terms of maintenance and MTTR. So at FEBUS, we took the party to develop all the technologies available today on the science market to make measurements on fiber optics. So that means being able to use a relay system to acquire acoustic, what we call DAS, that will give us a very long range. So more than 80 kilometers at a very low resolution, so we can detect things extremely low. So here it says 3 picostrains. That means that if you speak a bit loud next to an optical fiber, we're able to hear you. It's extremely sensitive, meaning that we can see very small effects, very practical for small dynamic measurements, since we can also go up to 400 kilohertz. So very nice to get nice big data to go to do some intense data processing to get a lot of information out of the asset we are measuring. That's the same way we can measure Brillouin, that's going to give you temperature and strain, static throughout the lifetime of the asset. And we can do it different ways, either a fixed or a portable version. So if we want to just some measurement campaigns, we take a suitcase, we go on site, we make a measurement, quite nice. And lastly, the Raman is going to be monitored through our T-series units, where you can really get quite a shorter range, but a more cost-effective solution to get temperature. At FEBUS, here I'm going to present in details all that fiber optic can bring in power optics, in power cables, but we work on a wide range of things, such as pipeline intrusion, even civil engineering and seismic monitoring. So we can do quite a lot of things. Please don't hesitate if you have other things. Now, for the interesting bit, how can fiber optic be used to monitor power cables? So the good thing is that there is fiber optics in all cables in a wind farm, may it be for the export cable or the inter-array cables. So this is quite nice because we only need to take one fiber out of this cable, out of the bundle of fiber, and it will be sufficient for us to make a whole bunch of measurements. And what type of thing can we measure? So first, there's going to be all that is thermal events. So either a hot spot, so a location where the cable is hotter than it should be. So that's going to create damage on the cable itself. We can also measure abnormal trends. So if it's becoming more and more hot, but it shouldn't be, we can detect it even before the temperature is too high. And of course, we can do what we call RTTR, also called DCR for dynamic cable rating, meaning that we can predict when a cable is going to overheat if we have the information on the power that is going through it. So once again, very good to make sure that it's, you optimize the lifetime of your cable. We can also, thanks to optical fiber, measure mechanical events, may it be shocks or even movements, such as free span, or even for on the output of floating devices on the dynamic cables to make sure that they behave properly. So it's very interesting. And we can also go for electrical events, such as partial discharges. So on this, we can detect and localize partial discharge events throughout the export cable and inter-array cables. And lastly, because this is for operation, so you get real-time measurements and real-time alerts, you can also do the same thing during installation to make sure that there is no issue while you install your system, so that you know if it's the cable that has an issue or if it's during operation or during installation. You can really identify where the issue came from. So now, to present a bit the 4-grid solution that FEBUS proposes, taking into account all that we presented. The main idea is to have everything in a cabinet that is communicating through a potential server, and from this server, you can get all the information that you need. All the calculation and data processing will be done, and the output, may it be the raw data or the alerts that are taken from it, are going to be made accessible, either to be used through your own hypervisor and data visualization system that you might have, or FEBUS has developed our own FEBUS 4-grid web solution so that you can access all the data directly through our viewer if you wish to. So this is a quick overview of what we can propose, where you have very high-level information, whether do you have a problem or not, green or red, very easy, and then you can go into more details. Where has the event happened? The overall trends, either against time or against distance, depending on what you want to do. So you can go quite far with this system, but of course, if you want to use your own, you can. And to be noted that it's web-based, but not cloud. It's just accessed through a web browser. Nothing is sent to the cloud. Everything is local. Everything is proprietary, of course. To talk a bit more about thermal events. So first off, it's going to be the very easy bit. We can measure temperature. So if we can measure temperature and we have a threshold not to go above, We simply put a threshold, and we can detect if one location goes above the threshold that we've given. So this is quite easy, and we can really do it quite nicely. But the good thing is you can go even further than this and look at trends. If it's getting hotter at a trend that is not normal, we can detect it and make an alert before it is bad. And the other thing that we're able to do is going to be able to dynamically optimize the cable so that it is always with the maximum power going through it without damaging it. Meaning that we can, thanks to a thermal model, the power going through it and the temperature of the fiber, we can come back to the temperature of the conductor. And it's this one that you want to make sure that doesn't overheat. So we can predict when is a cable going to overheat, or what output can I put through it to make sure that it never overheats. So this is quite nice. A little example of this application. Or here it's a project done with EDF R&D in Corsica, where the cable was buried at a different depth. And we measured the temperature throughout the cable. So you can see here the temperature against distance and the depth of burial against distance. And what's very interesting is you can see a direct correlation. If it's deep, it's going to be hotter because there is going to be less thermal dissipation. So it's just a very quick example on how you can qualify thermally how deep and how the cable is behaving simply by looking at temperature. Another thing that is quite interesting is when you want to use optical fiber to make temperature measurements, usually you're going to use Brie-1 because it's the one that gives very good results and that can go very far. But Brie-1 as a whole is going to be sensitive to strain. But you want to know, is it a thermal effect or is it a strain effect? So if you use only Brie-1, it can be an issue. But with FEBUS, what we did is we developed a G2. So this has been done through a PhD that has been working on it, and of course it's patented, to be able to fully decorrelate thermal events from mechanical events with a single measurement. Like this, we're sure that if we see a spike, we know if it's due to something mechanical or something thermal. We can really differentiate both. Now to move on to more mechanical aspects. So here there are different things that we can look at, either slow-moving mechanical aspects or dynamic mechanical aspects. For example, for dynamic, it can be shocks. Is there any shock or drag, or is there going to be too much current on the cable that is going to damage it? Is there a location that is going to see fatigue more quickly than at other portions? So this is very nice because we're able to detect shocks as well as to qualify the vibration at each location. Of course, for an anchor shock or an external event, for it, it's going to be easy because we're going to have a very high signal locally and we'll be able to know what's happened at which location. And we can even go further. For example, when the cable is buried, it's quite interesting because you will have a very good correlation between the vibration and the event, meaning that you can you can analyze the data in more details, and we've created a machine learning algorithm that is able to recognize the patterns as to know what type of event happened. For example, if we're speaking at the junction onshore of export cable, you want to know if someone is digging close to your cable or if someone is just compacting soil. Because of course, compacting soil is going to make a lot of noise, but there is no issue for the buried cable. On the other hand, digging, it's not going to be a lot of energy in it, but very problematic in case it goes up to it. So this is why machine learning can be very interesting to differentiate the various events. Here, another dynamic measurement of mechanical aspects. So what you have here is a measurement done in the Canary Islands, where you have the distance that it's in the x-axis and time that is slowing down. So that's what we're going to call a waterfall diagram, because time is slowing down. And we can see a lot of interesting things. First off, you can see that here we can go, it's been cut, we're more than 50 kilometers with a single measurement. So we can go very long range with very good precision. Another thing that you can see here is that we've installed the unit onshore. So first you have the onshore bed here that sees a little bit of noise but nothing abnormal. And then you can see all of this, which is quite nice. because it's waves crashing onto the beach that you can directly check because the cable is at the beach location, so we can clearly detect it. And then throughout the cable, kind of nothing happens, which is a good thing because the cable is supposed to be buried, except at various locations that you can see here, that you have those vertical lines, meaning that at specific locations, you are seeing a movement of the cable. But you shouldn't, because it should be buried. So this type of measurement is very useful, done with our FEBUS E1R. It's a DAS measurement, so acoustic acquisition, where you can clearly identify the location where you have potential issues. So meaning that you have a free-span section, or that you have something hitting of the cable. Well, in any case, it's not good for your cable. It's going to create fatigue. It's going to create weak points around it. So you want to know this type of information. So this was very good, and it can be done very quickly. We come in, we take 10-minute measurements, and we can have this type of output. So for campaign measurement, it's quite practical. But you have also the dynamic and the static part of mechanical aspects. Is it slow-moving or fast-moving? But it's always interesting to have both. So DAS measurements for very fast events, and static measurements to be able to compare measurements throughout a large period of time, several months, several years. So here it's a measurement that's been done on a floating wind farm, where you can see that with dynamic measurements, we see events with a cyclicity of about 6 hours, which is directly correlated to the tides coming in and out, where you can see mechanical aspects on the dynamic part of the cable. So this, you can locate it and you can quantify, you can see how it evolves, if it's become stronger or not. You can check if the cable is becoming in less good health or not. Quite practical. So this is good, let's say, on a daily basis, so quite dynamic. But you also want to look at monthly basis. So here it's a 3-month measurement. So you have to switch type of measurement so that you're sure that you're very stable. So instead of using a FEBUS A1, you're using a FEBUS G1, so a Brie-1-based unit. And here we can see the same thing. So this is done at one location throughout time. And we can see that you have those amplitudes with periodicity, but you see an additional period. So you have the small period that you see here, which is 6 hours due to each tide coming in and out. But you also have this cycle that comes in, which is due to the power of each tide event, which is about 1 month of cyclicity between low tide, low power of tide, and high power of tide. So this is very good because it gives access to information both on, we'll say, high speed, what is happening right now in a dynamic version for high speed measurements, and at more slower frequencies that can be compared for months, even years. Let's plug that back in. Perfect. So yeah, very nice to be able to monitor the quality of dynamic cables. This is really what we're able to do, as to get fatigue. Another thing that we can do mechanically is to check what is happening during deployment, because it's good to know once everything is installed that you have an issue, but it's better if you know beforehand, so that you're able to see during installation, is there an issue? Does the cable have an issue first? Or is the installation creating an issue with the cable? Like this, you're really capable of fully understanding what is happening with your system. So this is, thanks to our unit, we're very proud of having this. It's a fully portable unit, so since you don't need any communication or power added to it, it can be installed directly on a turret and just turn around and round with the cable during installation. With all the information being transmitted wirelessly, so that you can get all the data and know at each time, during the full installation process, what has happened in terms of strain on all positions along your cable. So first, now we've seen that we can measure thermal events as well as mechanical events, both static and dynamic. Now we're going to show that we can also measure electrical events. So for this one, unfortunately, I won't be able to show you a lot of graphs and technical informations because the patent is being put and we're seeing for confidentialities with the tests that have been done. But what we have proved is that we're able to detect partial discharge events and locate them in AC cables, meaning that if you have any partial discharge happening at one location of your export or inter-array cables, you will be able to locate it and to see how it evolves with time. Is it happening at a certain point and that not moving around, or is it really evolving and just getting stronger and stronger? So this is very good because once again, you don't need to add anything. What you really use is the optical fiber that is already installed on your cable for telecommunication. We take one fiber and you can get thermal, mechanical, and electrical events. So that's pretty much it for me. So just to showcase a bit everything that can be done with a simple optical fiber. You can plug a system inside and you get a lot of measurements. If you want any more information, of course, I'm free if you have any questions. Otherwise, you just make 2 meters to your left and we have our booth. And so don't hesitate to come and pass by. A bit of a brochure if you want as well. Thank you.
Thank you.